Okay. So yesterday we wrote out some of our orthogonal match column function here, which this let's see. This should be an all sides check right here. So if we go so as long as we pass in a column for this parameter, it will populate the fields of the surrounding stones. No. It'll only populate the field of that particular column that we pass in, and it'll populate whether or not it is matched with, right now we only got white, but if it is a white and it's got a match of a white stack control to any side of it, left, right, top, or below, it'll become true in that scenario. So we can test this here. We're crashing there because it's trying to index a value of our mouse, which is nil. So as long as our mouse is in the grid, when we launch it, it'll run. I need to figure out how to fix that overall, but I have not figured that out yet. So look, let's see if we've got right now, see how this grid in the middle has a true on the left match white, because we are white and the left match is a white. But if we add another stone beneath it, now we have a bottom match white and left match white. And then if we were to even cover up that stone, it would undo that left match white because there's no longer stack control. So we are flushing those appropriately, and we don't crash. We don't crash at an index of 1 up here, even though we'd be technically trying to index. This is why we had to do those 4 if statements. We're searching every surrounding grid here, but only this grid, and this grid for the top one, and only this grid, this grid for the bottom one, because we don't want to index a value off of our grid, because we haven't initialized those, and that's what gets our crashing, trying to index a nil value bug. So we worked our way around that. So the next thing we want to do is to start to implement our lateral connect function. So we already wrote a bit of this, but we're going to need to redo it. I'm going to go ahead and take these 2 lines and put them right before. We put him right here. We've got, so we're only going to check these orthogonal match now if we have a column, a stone in every column, because we can't have a road unless there's at least 1 stone of each stack control horizontally, at least for a horizontal win. We have to break it up to a vertical win too still. And right now we're just doing white stones, but now it should only test. It should only populate an orthogonal match if we've got a stone in every one of our columns. And then we're running this middle lateral connect, which we have to fix now. So the idea is we cycle through every grid. Oh, see, look, this is already jacked up. Why we have a nested I loop here, which we don't need. So we should be able to okay. We're just cycling through all the rows of our middle column. So since this is a middle lateral connect, we need to also ultimately check our middle left lateral connect and our middle right for our rows 2 and 4 respectively. But right here, we're just doing row 3, which is our middle. Now we have to be careful about how we do this because we don't want to index a value off our grid. So we can do what? So what are we trying to do? We're trying to, the current idea is to have this be a return true or false Boolean for this whole function, which we can then say, ultimately we want to say, hey, if we're first of all, if we've got a horizontal column stone stack control check, if we've got a stone in every one of our columns, then there's a possibility there's a road. So why don't we go, first of all, flush all of our orthogonal matches, then we're going to populate our orthogonal matches for our middle stack, because that's the first thing we need to check. And then we're going to run this middle lateral connect function. And that's hopefully going to say, hey, it's going to cycle through all the stones in our middle, and it's going to say, hey, if I is 1, if it's the top row, we need to say, hey, is our left match white and our right match white? And if so, then we've got a little middle lateral connect. But we've got to do this for every single possibility. So that includes a vertical connect, which is the part that's been so confusing. But now that we've got this left match stuff populated from our thing right here, bottom match, right match, left match, we generate that grid. Now it should be easier to do this. I'm going to go ahead and just insert a couple lines, and we're looking to do something like if I is equal to 1, then we want to do something along the lines of a top row check. What do we want to call this? Top row. Just leave it at top row logic for our middle lateral connect, because what this means is if our I is 1, then we're going to be saying we first need to check, actually, instead of doing this like this, we need to cycle through everything that is a left match white, because we can't have a middle lateral connect without having a left match. Now what that looks like in practice is kind of want to show something. So it's like, hey, look, we've got a white in every grid, in every column. We've got a white. So it would therefore be running our middle or our orthogonal match check, which at this point, since this one right here doesn't have a left match or a bottom match or a right match, they're all false right here. Let's go ahead and make sure that's in fact running. We've got a right match here, so it does look to be running. So as long as there's a stone in every column, we're running our middle orthogonal function, or middle match function, whatever we call that. But the thing is, we don't want to necessarily check every single row for a middle lateral connect, because we know as of right now, at this point in time, we know this can't be a road. Even though we've got 1 in every column, we know this can't be a road because none of our middles have a left match being true. So until we have a left match being true, we don't need to check for the right match because we know this is not a road. So we can just return false in this case. So it's not necessarily that we want to do, and look, I kind of had it right. It's not that we want to do this I is 1. It's that if the row in our middle column has a left match white of true, then we can say, okay, if it's got a right match of true, then return true. So here's where we need to add the sneaky stuff, where it's like, okay, first of all, if this grid has a left match white, then first we're gonna say, okay, now if I is equal to 0, meaning our top row, we're gonna say, because we need to check for rows beneath us, because we could have a middle lateral connect if the top one has a left match white, but the one beneath it has a right match white. That would also be a middle lateral connect if the second stone in a row is also a match white. Yeah, it's tricky. So we're saying, okay, you've got a left match white, so let's go ahead. Now, I think we need an else for this false, because this false is just kind of chilling here. Yeah, we can worry about the falses later, I guess, but I don't even know if this is a good way to approach this problem. But if yeah, okay, so maybe the first thing we can do is go ahead and do this. We say, hey, if the grid has a left match and a right match, then go ahead and return true right away on this middle lateral connect. Now we can say the return false is really tricky here because we want to return I'm not exactly sure how return values work. I don't know. My current understanding is that if I return a value, that function would exit. So if we accidentally return a false before we've checked all of the possible options, returning a false would make it permanently false because we only run this middle lateral connect upon changing placement or changing players. So I want to make sure we return false if it is false, but not too soon. I don't know how to do that. So we wouldn't want to put it else here. Let me just comment this out for now, I think. Okay. So if it's got a right match, sure, let's go ahead and return true right away. Because this is the case that we're surrounded. It's like a 3 horizontal stack of white control. That would be, okay, middle lateral connect for sure. Now the tricky part of the lateral connect is that we could vertically connect as well. And then, yeah, I think the way to do it is here. We'll start with 1, like, hey, if our I is 1 here, our I is 1. If our I is 1, this is already, we have to have a left match white for this point. So now we're going to say if, do we say if grid is not a match white? If it was a match white, we would have gone away and returned true already. So we should be able to just say if the one below us is a right match white, then go ahead and ask that. So we can say if the one below us, what is it, grid, if grid we should be able to hard code in this stuff because the row would be hard coded in. So maybe we just say the one row beneath us, but the same column. And we would say the same column if the one beneath us is a bottom match white. Now we don't have to actually do these equality operators because they're booleans themselves. So we should be able to just ask a question. It's like we should be able to go, oopsie, we should be able to go here and just say, we should be able to say that if left match white, so here's where we need to check the lateral. So I know there's a better way to do this, but I don't want to get stuck asking, hey, if we've got a white connect in the middle, we'd have to check all the aboves for a corresponding right match. Actually, maybe see, it's so hard to check whether or not a white match is connected to a left match. I don't know how to do it other than doing it explicitly like this. Because we'd have to check somehow, we'd have to check every grid in between and if it's a right match. So you know what? And what's even more confusing is we could have more than one lateral connect. Okay, we can have more than one lateral connect, and one of those could be a road and one of them could not be a road. But right now we don't have any way of signifying that. All we have is say, hey, there is a middle lateral connect. Which isn't so helpful. We have to be able to say, hey, this middle lateral connect function will go ahead and return true if there is a middle lateral connect, period. Yeah, that doesn't help us that much. It doesn't help us so much because we need to be able to test multiple middle lateral connects, or a first connect and a last connect. So it's almost like we need this function to either do something different, either return a different value, or we just make this a more complex function. Okay. I think we need to change this function so that it returns. How do we do this? Would it return a table of values of every column, of every row in our middle column that has a left match with a corresponding white match, with the vertical ones also being white? Because we need to be able to check potentially two different middle lateral connects. And right now, this doesn't give us any data other than true or false if there is one. But we need to run a first connect and a last connect on both potential or multiple potential lateral connects we have in the middle. Yeah. Yep. I have a feeling we want to make a table of all of the rows that have a corresponding left and right, what I'm going to call that have a lateral connect, a middle lateral connect. We want a table of all of our rows that are connected to a left orthogonal connect and have either a right match on the right side of that one, or have a right match connected vertically through other white stack controls. So instead of returning true or false, we need to add a given grid to our table of middle lateral connect columns, so that we can then say, okay, our middle lateral connect function gives us an updated table of any columns, any rows of our middle column that have a potential middle lateral connect, and then we run a first and last connect on both of those rows and their corresponding right match and left match rows. So it's a little disjointed because anything we would add to that table, its left connect would be that very grid off to the left once, but our right connect could potentially be many rows down or up from that current grid. So we would need a way to access what right match row we would need to check for a last connect. So that's a little tricky too. So it's almost like we need, anytime we have a match confirmed, we need to anytime we have a match confirmed, we need to somehow store the indexes of our left match and our right match. Now that's easy enough. This, I'm just realizing this should be, oh no, that should be right. Yeah, so it's like, we would need to save, this is tricky. We would need to save the indexes of our left match and our right match. Now, right now, left and right match are just a Boolean associated with the middle column, our middle column, not the actual match themselves. But we can figure it out through arithmetic based on the names. But then we'd still have to flush these false every time we update stack control and everything. I don't know what to do here because I don't know how many middle lateral connects we could possibly have. I feel like 3. It's so tough because I don't know all the combinations, you know, it's really tough. We need to somehow, I feel like we probably need to make a class called middleMatch grid, something like that. And that class would have, it would have a row associated, or what it would have, it would have coordinates for a left match, it would have coordinates for a right match, and it would also be coordinates of our grid that we have confirmed that middle lateral connect with. So if we write some fake code here for it and say, you know, if we've got a left match and a right match here, then we would know that we need to give ourselves, see, and this gets tricky, because we would give ourselves an instantiation, but we need to make sure that instantiation doesn't write over anything. And if we try to debug that, it'll just crash because it hasn't been initialized until we would have a left and right match. So what do we do? It's really hard to debug this stuff the way Lua is set up. We would have to, I hate having to do that. Like, we'd have to give ourselves these dummy values, these dummy instantiations of our middleMatch info, whatever we call that class we're about to write. We'd have to initialize a maximum of 5 of them with dummy values, and then only populate them with the right values when necessary, and then revert them back to the default values when necessary also, or when. I think we're gonna have to do that. And then that way we can just have 5 variables, all of which are object instantiations of our middle check. What do we call that? We would call it middle road info, middle horizontal road info, because if we're building a horizontal middle road, that has the it has the indexes of what our middle road would be, so that we can check first connect and last connect, which is the last step of determining a road. Because once we have those values to check, we can confirm a road or not. Building the road out from the middle, basically. At least that's my current guess of how to do this. check for stack control in each column, check for lateral connect with middle stack control. That's what we're doing right now. And part of that is checking a left match and a right match. The vertical connect is what we're stuck at because we've already got a function to kind of determine this, but we need to check for the verticals. And then we need to pass that info to a new function called first connect, last connect with all of our middle match objects. So like any row in our middle column that has a left match and a right match, but then how do we not get duplicates? Because if they're touching, it would kind of count as we would get more than one middle lateral connect. This is tough. Let me see if I can illustrate this. So like, imagine we've got white in every column, but then we would be going through, starting at the top, adding in all of our middle match class instantiations that we still have to write if we do it this way. And we would say, okay, we're at the first of our middle row. Does it have a left and a right match? Yes, it does. So go ahead and add this grid to our middle match instantiation grids, or objects, whatever you want to call it. Then it would go say this has no left match, this has no left match, so it wouldn't bother with those. But then here it would say, okay, well this has got a left match, does it have a right match? Then it would go up and check here. Then it would add this grid to our middle match objects, which is very different than adding this one. Even though they share the right, it would mean our right connect function should turn out the same, but our left connect wouldn't, because our left connect is based on where we're actually connected to our middle grid. So I think we actually are in a decent shape there, because we would want a separate, basically we're storing in our middle match class, we're going to be storing the grid at which our left is tethered to. So we can only ever have 5 of them, which is why we need to have those 5 dummy values. And then each of those will only point to something with a corresponding right match, and it would be by default pointing to a different left match than the previous, because it can only have one left match. So I think that is one way to go about it, and it's making the most sense to me about how to tackle it. Easier said than done though. So we would do something like, hey, we would populate at our I. So if we have our middle match class, what would we call it? We would call it, it would be a new class. I think class convention starts with a title, so we would just call it middle match info. I mean, maybe just middle match. And it would be this this notation, table notation? No. It would be a class, it would get a table, but then to instantiate it, we would, I don't exactly know. Let's see the top of our file. We have, it would be right here, we've got a board that gets a board instantiation. It's just parentheses. So we can go ahead and say our middle match instantiation. Now we want, see, this is hard too. How do we dynamically insert? No. We can do this. We can, oh God. We can do this by saying, we would know that, see, no, this is hard because we're trying to convert we're trying to convert this I to a string so we can append this middle match object to a variable name holding the corresponding number of that middle match because we have to populate them with dummy values. So in this case, if this is 1, we need to say, oh, this grid is 1, therefore put it into the middleMatch 1 variable, which is the dummy or the stand-in class. I don't know what you would call that, but I don't know how to convert this to a string into our variable name. Don't know how to do that. And we have to keep them. Gosh, I don't know what to do there. But basically, because we wouldn't be instantiating the middleMatch object here, but we would be, oopsie. Oh no, where did I go? Yeah, right here, we want to do, what we don't want to be instantiating them there. We'll instantiate them upon our init place state, but then we would be modifying the variables that they're at. So like middleMatch 1, if this is a grid 1, we would be modifying the first one. So I don't know how to kind of do this smartly. I guess we would just ask it. Yeah. I guess we can do this where we kind of do it like we ask the I first, and the first thing we do in every I is check for a left match and a right match, but really want to do that. But that would give us access to the correct I for when we populate our middleMatch objects. There's got to be a better way to do this. Because instead of saying middleMatch like that, it would be more like middleMatch 1, which is an object which has a field of origin row or whatever we call it. We would be assigning that, and then we would also call them, but then also left match row, left match row, because we need the variables. We need to be able to index the left match grid, which has a row and a column. So we would have row and column here getting instantiated anytime instead of returning true, we would actually be populating our class with these useful data. But I don't know how to do it dynamically because we don't necessarily always want it written into match 1 variable. Because we don't want to necessarily overwrite things. Want it to be nice and tidy. We're coming up on it, we're figuring it out. I just don't. Yeah, I think the way to do it is just to cycle through. I think we're gonna have to ask this question 5 times, which I don't like. But depending on which grid we're at, changes which variable we need to modify, and I don't know how to modify a variable depending on a local variable. I don't know how to do that short of splitting it out explicitly, saying, hey, if I is 1, I know which variable to name. If I is 2, I know which variable to name. So that's why I think we kind of have to delete it out there. But don't, maybe we would say, you know, if I is 1, then go ahead and check hold on a sec. If I is 1, then we'd say, hey, if grid, we can just replace this with a 1. If no. If we know it's the third column, and then yeah, we know if we're row 1. Yeah, so if we know if row 1's got a left match white and row 1's got a right match white, then we are in fact needing to store a couple of things. We can combine these. Is that what and looks like? Does and look like that? Yeah, it does. I don't think I like that. Well, we'll change this in our color scheme. I don't like how the equal signs, or the equality and the and conditions are gray. I think this should be brighter. We'll do that. Or I'll do that off stream, but we can go ahead and delete this stuff now. So we're gonna say we've got too many ends here. Okay, here we go. So we would be saying, okay, if we're at our top grid and we've got a left match and a right match, then go ahead and we would just go ahead and assign middle match 1 variables. Now the variables will be different until we wouldn't assign these, and the number here is our row of our middle column. So 1 would be our top middle, and we'd only assign these values to be anything other than the initialized false values or nil values. We'd only want to assign them if we have a corresponding right match, which we still have to determine by going through checking a bottom. So like we can say, you know, else if we've got that grid 1 3 dot bottom match. So like it could still get assigned a middle match object if the left match and the right match aren't both true. It would have to be a left match true, which we'd have to ask. So we would have to ask this. We can say we would need this. We can say nope. Visual mode. Yeah. Else if we've got a left match and ooh no. That, and we'd got a bottom match. Then we would see if the bottom match has a right match, and then we'd have to go through this loop and say, okay, well no, if we've got a left match, then if we've got, yeah, so we can break out this left match to be at the very top. We say, okay, if we're a left match, check all these things. If we're a right match, go ahead, assign our middle variable right away. If not, check our bottom stone for stack control. If we've got that, then go ahead and, yeah, instead of checking, yeah, you know what? We don't even really need the bottom match and top match because we can ask stone control, because that's all it is really. And we know which grid we would need to ask stack control for. Stack control, not stone control. Yeah, so we would be doing, something like this, where we would say, or we'd go ahead and ask if it's the left match, and then we would nest the rest in a, okay, if match, come on. If left match white, then we'd go ahead and then check this. And then we can say, cool. Nope. Shift O. Nope. Just O. Cool. Just O, and we'd say end. Why does it do that? I don't know why I keep accidentally going to search function. Previous search. What is? I'll need to look up whatever the hotkey is for previous search because I keep accidentally doing that. But that was weird. Insert. Okay. So yeah, we're first checking if we've got a left match white, because if we don't have a left match white in that grid, we can't populate that grid with a middle match variable, because every middle match variable needs a left match and a corresponding right match. Granted, maybe vertically connected, but it's okay we check for this left match at the beginning here. That means we can delete this. We can delete this, and then we can say if it's a match, if it's a left white match, then if it's right match, go ahead and do this right away. And then we can say otherwise if we've got a bottom. Yeah. We can say something like this. Nope. Okay, so if we've got a left match white, do we have a corresponding white match? If not, does our bottom? Yeah, so this is just the code for our row 1. And I have to split this up because I need to know which variable to actually modify with our middle match object. And I need to know which row we're at, because that changes the logic we're checking for a vertical match. Because if we're on a row 2, we need to check not only for our right middle match, but if it doesn't have a right middle match, we need to check above it, and if that is our stack control and that one has a right match, or if the ones beneath us have a right match. And you know what? Yeah, we might be able to tether in some ores for those. So like, so it's like, if it's a left, in this row 1, if we are in fact a left match white, then if we're a right match white, we'd go ahead and populate it right away. But else, if we've got a bottom match white, we're gonna ask, okay, does that next grid beneath us have a right match white? If it does, go ahead and populate that good stuff. We would actually need to continue through the whole list and check any continuous right match whites with our stack control. So we would have to go through every single way, because we could have multiple roads branching out, and we need to add all of those potential roads to our middle match objects. Shoot, that's even more problematic though, because but let me think. Yeah, that's problematic. Because we were assuming we can only have 5 middle match variables, but that's not the case. We can actually have more. We could have more than 5 potential roads from the middle column. And that's because they could share a left orthogonal match and share a road. And we would need to check each one. Yeah, I could share a vertical road. Yeah. Okay. I think... Oh God, I don't know what to do. I'm gonna have to stew on it. Part of me thinks we just need to add all of the further road detection logic right away in this function. But I don't think that's the right. I don't know. It's really complicated because, yeah, we can have more than 5 middle match objects. More than 5 potential roads based on our middle column. We could have more than 5 potential roads. And we would need to check each one of those for a first connect and last connect. If I was smarter, it's almost like, because what makes it even more complicated is the one that we're a right match with. We're not just checking to see if the very last column for our last connect function, we're not just seeing if our very last column is directly orthogonal to that middle stack, but also if that one is a vertical connect. So that's a whole nother heap of more than 5 potential objects we need to populate. Oh my God. I really don't know how to tackle this one at the moment. Yeah, I don't know. I need to rethink this a bit. I was on the right track with, we know that we do need to be able to test certain grids for a first connect and last connect. But the hard thing is, we can test more than 5. It could be possible that we would check more than 5, no? Because potentially let's just see this. Potentially we could have, let's say we've got like a row going, but then we've got I don't know. It's tough because the thing I got when I'm trying to figure out how to code this win state, I've determined it's very hard to count whether or not any possible direction is a road or not, but it was easy to either prove or disprove a road. So if we go about it in the sense that see, because right now, like looking at this, it's clearly a road going from left to right, but in my code, it wouldn't know that yet. So it would go through, it would say, okay, this one doesn't have a left match, this one does have a left match, and then it does have a right match. So it would know it's at least a possible road, so it would get added to our middle stone objects or instantiations. But then it would also be connected vertically to something that would be a road. So if this one, shoot, it's hard to illustrate something that would prove the difficulty. But basically, instead of saying what am I trying to illustrate? Like if there's more than one possible road for any left match. So it's like this left match has got a road opportunity down here as well. Nope. Let us so if we look at this. So look, this is a road in two different ways. And it's a road in two different ways that are both counting on this middle stone, because this middle stone is the only one with an orthogonal connection to this row 2 and only connection to this row 1. So with my logic that I was talking through today, it would be going something like this. It would go through, this doesn't have a left connect, so it would go down to this one. This one does have a left connect. This one does not have a right connect, so we would therefore check if we have an above connection, which we do, and if that above connection has a right connect, which it does. And then at that point, it would be adding it to a middle stack or middle match object, which is a class we haven't written yet, but that object would hold a grid about where we were, and it would hold the grid of our left match and the grid of our corresponding right match, so that we can check whether or not our right connects and our left connects to the first or to the fifth row and first row respectively. So at this point, it would add this one to our middle match based on, and it would lock in this grid. Now look at this, like right here, it would be fine if we just added that one to the grid, because by the time it would go around and ask, okay, does any of our middle match objects have a first or last connect based on those two variables, or those two grids that we've saved? And then it would be like, yes it does, okay, we've got a road. But the really tricky part is that if that part, let's say that this part ends here, and it's hard to, so like now we've got, and ignore that we've got a white, actually I can just move this over here or something. just... So now look in this scenario. We'd be going through, we'd have this, it's got a left connect. Okay, does above have a right connect? Yes, it does. Okay, add this to the potential middle match grids. But we're missing the index of this one, which is actually our complete horizontal row. So we do need more than 5 potential variables, and we can't just index them or name them based on our row of our middle stack, because in a scenario like this, it has more than 2 possible middle matches. So the question is, it's hard because we can't lock in. We don't know for a fact that this one is a dead end until we check all of the bottom connects and top connects for a right connect. Maybe there's a different way of doing it where we say, okay, well, we've got a list of all of our... Shoot, man. I don't know how to do it. We've got a list of the 2 rows in our last column that could potentially fill out the last of our horizontal row or road, right? So we can say, okay, so now when we're checking our right match, we're gonna ignore any match that may not have a right connection, but that's not exactly right because it could have a vertical connection, and then I don't know how to do it. I don't know how to do it. I think I'm onto something with, we know that this would need to be connect. So it's almost like we need to do a last connect first. No, I don't think that's right. I was thinking that maybe if we populate or yeah, geez, I don't know. If we ask, before we even do a middle match or whatever we're doing, middle orthogonal fields, we would populate a table of all of our potential row 4, column 4 roads. So in this scenario, this grid right here would not be added to our potential row 4 roads because it is not vertically connected to a white stack, and it is not orthogonally connected to a white stack either, so that's a dead end as far as a horizontal road is considered. These 2 would be possible, and then we can go ahead and then when we check our middle check, we say, okay, if we're going through our middle check, if the right orthogonal is a dead end, just ignore it. We're only worried about non-dead end orthogonal pieces. So then it would say, okay, well, do we have one beneath us? Okay, yeah, we do. Do we have a right match there? Yes, we do. And then by the time we do last check, we would say, okay, it is a road over to this way. But that doesn't fix the problem of us having multiple roads, because we could potentially have a white here and a white here, and then a black here, and that would make a road this way, but stop right here. But yeah, that would only be... I'm wondering if there's a way we could have 2 possible roads and... No. I don't know. Because ideally, by the time we check this, we say, okay, well, we've got a left match, we've got a right match. Does that right match have a corresponding right match. Shit, I don't know. It's so hard to make sure that we return a true on a road like this, you know? It's like every possible combination has to be accounted for. And that's very tough. Yeah. I don't know. I'm gonna have to think it over and try to figure something else out. We can't just have 5 middle stone match objects, because we've proved that it's not that simple. So my next kind of game plan is to write a new function that's all available, or like it would be changing the grids here, every row at column 4. It would change all of these to a either yes, it can be part of a road, or no, it can be part of a road based on the last connect. And then once we've got that, then in our middle check we can say, you know what, if that row can't be a road, don't even bother locking it in, don't even bother last checking it, because we kind of already did last check it. We would just say, okay, at that point. And then same thing with our first connect. If we would populate based on how many stack controls we have in row 1, in column 1, we would change any row in column 2 to be true as a part of a road if it is left connecting with one, or vertically connecting with one that is left connecting with one. Jesus. This is very hard. If I can figure this out, though, I'll be super proud. It's just very hard. Because I'm thinking if we can disprove it before we even assign the middle matches, we can disprove any road before we assign those middle matches, that's less middle matches we'd have to check. I just might have to think of it a different way. I'm just not sure. Yeah, I think the way to do it, I think the way to do it, like I said, is just either we prove there's a road or we disprove a road. Like that's, instead of checking every possible branch you could possibly take, we're trying to just, hey, is that a road? Like, let's find out the shortest road that can be, if it can be one, and just return true if it is a road. So how, like, I'm thinking if we do like a weird ass road like this, right, where it's like a Z, how would we prove this road right away? Well, it would go, right now, it would go through all of our middle stack and say, okay, well, we need a left connect. And it says it's got a left connect. Now we need a right connect. Then it would say, okay, well, there's no one here. There's a stack control here, so let's check here. No, there's a stack control here, so let's check here. No, stack control here. There's no here. Stack control here, so let's check here. Yes. Then it would say, okay, add this to a middle match stone with this variable, and then we check this one with the first connect, which is true, and this one with the last connect, that's true. But then what I just said was like, okay, what if before we do that middle match check, we say, okay, we know that there's only a white stone here, and there's only a white stone here. If there's only a white stone here, then we need to make sure any white stone here would need to be orthogonally connected to it or vertically connected to it. In which this case it is orthogonally connected, but it could be a white here, so if there's a white there, we'd say, we would know this can't be a road, at least a horizontal road, because let me just make this not a road, so. So yeah, maybe we ask, okay, there's one in every column. Now does our last one connect orthogonally to any white or vertically connect to any orthogonally white? And another way of saying that is saying, does our fourth row, does anyone with our stack control there either share a border with white or share a vertical with that white? Oh my god, it's so tough. It's so tough. I still don't know a game plan, because I think even if we rule out those things, we still have to potentially check more than one grid, more than one of our middle rows we'd have to check first connect and last connect with potentially two different right orthogonal matches, which I'm still not sure how to do. God damn it. I'm gonna have to think more about it. I don't know what to do. Yeah, I don't know what to do. Actually, if we take a look at our git diff, we've got we moved our orthogonal match to our horizontal check, and then we changed a bit of our code of our middle lateral connect. We really, god damn it, we really didn't do much of anything. Yeah, I mean, most of what we did today was theorize about how to do this. Yeah, I want this to be green. I thought I fixed this to be green. What the heck, man? I mean, this is still in... Oh, you know what? This is still in Vim. So maybe if we... Yeah, maybe if we run a git diff here, it'll show it. No. Oh, yeah. Okay, so now we've got the brighter. Got the brighter green for the stuff we've added instead of the gray. That's easier to read. So as long as we do it not in the Vim terminal, but in the actual terminal, we'll be able to read it. And then, or with these other colors. So yeah, we really didn't do much. We really did almost nothing except wrap our head around the problem. And the conclusion was, it's a hard problem and you can't go about it the way I assumed I could. But that's okay, like we know what doesn't work, we just need to find what does work. We get add everything with a commit message saying, we didn't do much of anything, so it's hard to say anything. We just, starting to figure out middle match tests. I don't know what to say. That's a horrible commit message, but if we look at that commit, it's like, yeah, we're building the logic for our middle match tests here so that we can determine a road. We just didn't get very far. Anyways, I'll see you guys tomorrow, and hopefully we'll get more stuff done. I feel like I'm gonna have to really rack my brain over this problem tomorrow to get a game plan, or tonight even to get a game plan for tomorrow, because at this point I don't know which direction to go, because the direction I have an idea for isn't a solution. It's only a partial solution. So I need to figure something out. Yeah, I'll work on it. It is possible. I know it's possible. We just have to figure it out.